E5. First thing, proportional relationships. Always go through what point? What point do they always have to go through if it's proportional? 0, 0, the origin, okay? And it's going to be a straight line, right? So it's going to go through 0, 0. This is going to be our point at 0, 0, and then it's going to be a straight line. And that straight line can be really steep, or it can be really flat. But it goes through that 0, 0 point, okay? Key thing when we write our equations is you were looking at the E4. We wrote equations in y equals mx, where we were thinking, so please write this in your notes, y equals the slope times x. But we have not been using that word slope. We have been using the word unit rate.
So missing lap.
I want you to write y equals, and instead of the word slope, we have also used in our homework the unit rate. Okay? So it's unit rate times x. We're going to be looking at graphs, tables, and trying to look at proportional relationships. So this is comparing distances, and we are looking at this data, and as we look at this data, it says we're looking at distances from the city of Fargo, and we're trying to draw a graph, write an equation that takes the relationship from miles and kilometers. So above the miles, please put x, and above distance, please put y. We're going to try and find out these two missing ones, okay? But we're going to kind of use first our graph to try and figure it out and make an estimation, and then we are going to look at our data, writing an equation. So it says, the first 6 points of the data have been plotted, where x represents the length in miles and y represents kilometers. What pattern or shape do you know if we were going to graph that? So what could I draw connecting those points? A line going through what point? 0, 0. So let's do that. Please go down to 0, 0. And there's some protractors around on the desks, and I'll hand out a few more. But so add 0, 0, and you want it to go through all of those points. And draw a straight line. And do you think I should have an arrow on the end?
Yes.
Do I need an arrow down here at 0, 0? No. Okay. So what pattern did we see in our graph? A line, and it's really a ray, would you agree? Up like that, right? So it's really a ray that we are looking at. So we connect the points to illustrate our pattern. Do we start at the origin? Yes. Do we put arrows on the line, one end or both? Just on one end, right? And the reason it can't go down here is because what can't we have for our distances? Distance can't be negative, right? Distance cannot, please write that, be negative. And it says, okay, so now if we look at our graph up above, we were looking at the city and we were trying to find when Omaha, which is 424. So where do you think 424 is going to be? That'd be like 450 is in the middle, so about a fourth of the way here, right? That's going to be 424. Could we estimate how many kilometers? So take your straight edge and draw a line going up and check with your shoulder partner and say, you know what I think, and my line kind of got a little crooked, but you can kind of, how many kilometers do you think? So talk to your shoulder partner right now, please. Draw those lines and see what your estimate is. I want you to both come up with an estimate for how many kilometers, okay? At 424 miles, approximately how many kilometers, okay? 690. Lucy, did you talk? No, you need to talk. Did you talk with your shoulder partner? What do you guys think, Cody? 680. Other estimates. Brylan, did you talk to anyone? I know, but there's other people by you. All right, go for it. What'd you have? 695. I would take all of these answers so far as being correct, right? We didn't use an equation. We just kind of approximated by looking at this. Is there any way of telling the other distance you were looking at in that table was 1,374 kilometers? Can we approximate where that would be? from this graph?
Oh, no.
Not really. Okay, so what we're going to do is we're going to look at a couple of different ways. So it says look back at our table. We want to find the unit rate. Unit rate, Nolan is reading, says to do it which way? What do they tell us to do for the unit rate? What unit? Kilometers per mile. So the per is our division. So what word do I want on top? Kilometers, right? And you can abbreviate it. And we're going to put miles in the denominator. So I'm going to look back at that table. Hunter, would you read us, tell me a city from Fargo. Pick one of these cities, not Omaha or Denver, but one of the other ones. Bismarck, and okay, so if we're looking at Bismarck, what was Bismarck's kilometers?
315.
315. And the miles was?
196.
How much?
196.
196. Okay? So please take your calculator and divide that. 315 divided by 196. Timothy, I need you to pick another city. So that was Sioux Falls. Pick another city up towards the top.
Billings.
Billings, okay. How far was Billings in kilometer?
980.
980. And we're going to divide by
609.
609. Divide this one also. And we want to pick one more. So get a calculator. Okay.
This town for the Sioux Falls is actually cheaper.
Oh, that's Bismarck? That's okay. We can still use it. 315 to 196. Okay. All right. What do we get? Deshaun, when you divide, you got a calculator?
No.
No. Check with your shoulder partner then. See if she'll share. Those of you without calculators, most of mine have disappeared. 1 point, what'd you get? 1.61. Ah, try it. See, do you get the same thing? 1.6? Did it come out the same? 1.61? 607. This was 1 point, if we're going to estimate it, 1.6. This 1.6. If I take any of the kilometers and divide it by miles, do you think I'm going to get 1.6 for all of them?
Yeah.
And we could try it. We could divide a few more. But we now know this is our unit rate, right? So our unit rate in kilometers per mile. So we want to write an equation. How do we say we write our equations? Y equals unit rate 1.6 times x. What did the Y stand for, Isaac? Which word? Miles or kilometers? Kilometers. And x is our miles. So what they ask us to do, it says now use the equation to find the missing distance from Omaha and Denver. So Omaha, what we knew about Omaha was that it was 424 miles. Which means in this equation, y equals 1.6x. Should I replace the x with 424 or the y?
Why?
Which one is miles?
Oh.
X. So we're going to put x equals 424, and your answer is going to be y equals, we're going to take 1.6 times 424. Now, those of you, if you don't have a calculator, yes, on your computers, you could open it up and just turn on the calculator and only have that, okay? And all you have to do is type in calculator and it'll come up. But we're not going to do that right now, but Maddie, what'd you get? Addie, sorry.
628.4.
Okay, so when we look at all of those distances, notice that all of these distances didn't have decimals. So we're going to round it to the nearest, in this case, kilometer. So how much did you get? So we're going to put down 678 miles. 128. Are you sure?
No, I'll do it.
Check it one more time. I thought it was 678.
Oh, it's
All right, good. So now we're going to look at Denver, okay? So if I'm looking at Denver, Denver is measured in kilometers, and they told us it was 1,374 kilometers. So is that my y or my x this time, Lucy? That's my y. So y is equal to this. So now what I'm going to do is I'm going to still go to that equation, y equals 1.6. And in place of y, I'm going to put in 1,374 equals 1.6x. And when we solved equations with our last unit, what do I need to do? Not multiply by 1.6, but if we are looking at this. So this is right over here where we're doing this. Yep, that's all right. So we are going to divide, in this case, both sides by 1.6. So on your calculator, please take that 1374 and divide. So those of you, this is on the top of page 16 in your notes that you've just filled in. Doing the division, Connor, what'd you get? X should be 1374 divided by 1.6. It's going to be less than 1,374. 858, and at this point it's 0.75. So I would either take 858 miles, or I'd take 859 miles, right? Because they always rounded it to the nearest whole number. So we're not going to put our answer as a decimal because all the numbers in that table were to the nearest mile, okay? So this is how in your homework you will be doing some of the questions. You'll come up with the unit rate. You'll write an equation. Sometimes in your homework they'll tell you the x, and if they tell you the x, you're going to replace that in the equation for the x. And other times in your homework that you're doing tonight, they're going to tell you y equals. Then you replace the y and you do division, okay? But this is pretty much as you look at this for some of the stuff you're going to be doing in your homework. We're going to watch this video. The video, he goes a little slow in it, I believe. Right. So this is going to take us pretty much through the end of the period. There's part of it that you will be working on with your shoulder partner. There's part of it where you will just be listening. And I know it seems a little slow at times, but hopefully after this, you will have this down and you will not be confused with your unit rate and looking at your solutions as you are looking at these. So,
and interpret proportional relationships from graphs and equations.
and yes, he kind of plays with an accent.
Oh, that's it for my British accent. Now, remember, if a graph line intersects the origin, all right, we've already done this. All right, if a graph line intersects the origin, the values, all right, in the table or in the graph are proportional. All right, if a graph line does not intersect the origin, the values are not proportional. All right, but you already know that. So get this down. All right, and that's it for this slide. Next one.
This is exactly like your notes.
Okay. Now I know we got a lot going on here. All right, so we're just gonna work from left to right. Okay, so let's just worry about this graph. All right, I'm expecting you to have this in your notes. All right, so take your time on it. This graph is going to represent the cost of some shirts. All right, now this right here, that's the y-axis. All right, the cost of the shirts in dollars. All right, so that's what 0, 5, 10, 15, 20, 25, 30, and 35 represent. They represent the cost in dollars, so that's $5, $10, $15, and so on. All right, now y is also known as a dependent variable. All right, D-E-P-E-N-D-E-N-T.
Write it right below it.
Dependent
Right below
variable.
the Y, right?
All right.
Dependent.
So I want you to get that in your notes. That's something that I'm not writing down, but I'm saying. Get that in your notes.
Right
This is
here.
the dependent variable.
Write the word dependent.
This right here, this axis, this is the x-axis. All right. The x-axis always represents the independent variable. All right. So there's the second thing I want you to write down, that aren't going to be, or that isn't going to be written on my board. This is the independent variable. Y is the dependent variable. The reason for that is because this, the cost, depends on how many shirts we get. Alright? The price we pay, it depends, it's dependent on the number of shirts we get. Alright? So for example, one shirt costs that much, two shirts that much, three shirts that much, four shirts that much, five shirts that much, six shirts that much. Now, you're going to notice, and you're going to notice this when you analyze other graphs, wherever the line that's graphed intersects both lines on the x-axis and y-axis, alright, right here, see how it crosses, we got that dot right there at that intersection. That's going to be the easiest way to read the graph, or at least to start off reading the graph. Alright, so what this tells us, because these are in the middle, I don't know how much that is exactly, I don't know how much that is exactly, or that amount, but I know this is exactly 30 bucks. Alright, and that is the cost of 5 shirts. 30 bucks for 5 shirts. So now in my table, alright, I've got the number of shirts, and I've got the cost.
Your next problem you're going to do is going to be set up just like this. Put your X
value, alright, and the cost in dollars, that is our Y value. Alright, now, we don't know how much 1, 2, 3, 4, or 6 shirts is, but by looking at the graph, we know for sure that 5 shirts cost 30 bucks. Alright, we know that 5 shirts is 30 bucks, so next to the 5 shirts I wrote 30 bucks. Alright, we don't know these other values because the points, they don't line up perfectly with our values, okay? So we're really not quite sure what they are. The way you figure it out is to change this rate into a unit rate. Alright, there we go, we've done this before. It's $30 for
This is how you'll be
5
starting.
shirts. So let's turn that into a
We
unit
showed
rate,
dividing
right?
them
Make
both
that
by
denominator
5.
1. So how can we turn 5 into 1? Well, we divide by 5. And whenever you do to the bottom, you got to do to the top. So I've got divided by 5 on top, divided by 5 on bottom. And you know what? That's another thing. The last thing I want you to have in your notes that is not written down, alright? Star. Put a star next to everything that I say that I want you to write down that isn't on the board. That way when I check your homework notes, I can just look for those 3 stars. All right,
You won't
remember
actually
to
be
do
coming
that.
to check your homework.
I want
But
you
I
to
will be
write down
walking around track.
that whatever you do to the top of a ratio, you have to do to the bottom of a ratio. Whatever you do to the top of a rate, you have to do to the bottom of that rate. Alright, write that down. Whatever you do to the top of a rate, you have to do to the bottom of that rate. And whatever you do to the top of a ratio, you have to do to the bottom of that ratio. Alright, and that's it for what you have to write down. Now, so this turns into $6 for 1 shirt. Alright, so now I can really start to fill this table out. 1 shirt is $6. So, I've got $6. Well,
Right? So you can
you
fill
all
in your whole
probably know
table
this,
pretty easily.
right?
You didn't put the
If
right
1 shirt is
numbers,
$6,
writing in beforehand.
2 shirts must be 12. 3 shirts, that must be 18. Notice the pattern? Up 6, up 6, up 1, up 1, up 1, and so on. Okay? 4 shirts, that must be 24 bucks. Now, what can I do?
Make sure you leave a
Because
space right
6
here
and 9
when you
equal
leave
1.
this.
Alright, right now that
So
doesn't
put
make
this
any
as your
sense.
Y, leave a space,
What can I do
and
to
then
the
put the
1?
1.
That's going to turn this into 6, so that 6 equals 6. Well, we can multiply 1 by 6. So I can do 6 times 1, right? Alright? Next one. Y is 12. Okay, so Y is 12. X is 2. Alright, again. 12 doesn't equal 2. What can I do to the 2 that's going to make 12 equal 12. Well, I can multiply the 2 by 6 again. Alright, notice the pattern. Multiply 6 by it. So let's just finish this
So leave
out.
space.
Y is 18, 24, 30, and 36.
Your 18 equals
18, 24, 30, and 36. And then X is 3, 4, 5, and 6. So I'm going to write in 3, 4, 5, and 6. And then again, notice the pattern, guys. You just have to multiply 6 by whatever X is to get Y. So I'm going to multiply 6 times 3 to get 18. 6 times 4 times 5. 6 times 6. So what equation can I write now that doesn't have any numbers in it? Alright, besides the one we're going to plug in, but it's got Y and X in the equation. Well, look, the way we get Y is to multiply 6 by whatever the X value is. So, my equation I'm going to write is going to be Y equals 6 times X, or 6X. So Y equals 6X. So now, I mean, I could give you a problem like, alright, let's say it costs me, I don't know, how about maybe 120 bucks. I spent 120 bucks at the mall buying those shirts. How many shirts did I buy? Well,
we know
Y is
120
120.
is that the Y or
And
X?
6 times the number of shirts is 120.
Take
X must be 20. Alright, so we can now use this equation to solve any problem that deals with a number of shirts.
So we are going to be doing this, finding missing ones where sometimes you're going to know
Again,
the shirts.
Y X.
Other times you're going to know cost. This is the top of the next page that you're
Alright.
going to be doing on your
Write
own.
all this down.
Part.
Alright, title your graph. This is the cost. This graph represents the cost of cell service minutes, alright, for your cell phone. So here we've got the cost,
So right
and this
down here we
is
should put what word?
x-axis represents the number of minutes.
Be
Again,
independent, right?
y-axis
Independent
represents
of
the
X.
cost, x-axis represents the number of minutes.
By Y, please
We've got our
write
table,
your
and we've got what we're going to do to solve the situation. So once you get all this info down, try and complete the table by the x value to get the y value.
So if we are looking at this, I want you right now.
This is it's somewhere in between 30 and 40. We've got our table, and we've got what we're going to do to solve the situation. So once you get all this info down. Alright,
So it is important that you're
this
writing that
becomes
divided by
3
20.
cents. And this becomes 1 minute.
Labels. Dollars in the numerator, minutes in our denominator. You can't
So
come
that
out
means
later with
that
our
1
labels.
minute costs 3 cents. Alright? Every minute I get.
And this is where I saw most of your tables.
Alright, so let's use this as an example.
Look at times 3 cents times 2, 3 cents times
And you know
4.
what? There's going to be one more thing I'm going to want you to write down for credit. Alright, so you know what? It's actually going to be 4 stars on this video that you're going to have in your notes when I come around and check your homework. Alright, look. Y is 0.03. Alright, so Y.
I know some of you are thinking, oh, I can just put 3 and 6 and 12. No, these are 3 cents. It is 0.03. It is 0.06. So I'm walking around looking at some of yours and you're not being very precise. So make sure that yours looks like this.
Is 0.03. X is 1.
Leave
Alright.
space, right? Because you got to put in that 3 cents for your unit
What can I
rate.
do? What can I do? 0.03, huh? You can just multiply by 0.03.
So he goes a little slow at this
equal
point,
each
but
other.
I'm
Well,
gonna.
I'm going to multiply by 2 to get 0.06. I'm going to multiply by 0.03 again. Just like the last one. We do the exact same thing.
And I had someone say, but why does it
3
matter, Mrs.
times
Thompson?
12.
Can't I put the 1 first and then point times 0.03? We want unit rate times x. X is our
So that means
independent variable. So making sure you
when I
read
actually
this
write my
is
equation out,
not
y equals something times x.
3.03, okay?
Alright, see how we had to multiply x by 0.03 to get y? Our equation then is going to be y equals.
I've used it a few times, but so when you go back here, I am looking at yours, right? I would have had here 28. I'm going to have 0.03. And in this case, what do we have 28 was equal to?
0.48.
0.84. So that's my 0.84, 0.84, that's my y, is equal 0.03. And sometimes people like to put parentheses, other times just a point. So your whole table should be filled in and all of this. Now, what's nice is that any time you are looking, and if you have 1 in a table, that's your unit rate. And in our equation, that will be the same thing. So this number will be here, it'll be here with the 1, and if I would go to 1, I would find it right here on my graph. This one is hard to tell because of the scale they use. Your homework tonight, so tomorrow we're going to have a quiz where I'm going to be asking you to find a unit rate and to fill in a table, just like we just did. Tomorrow we also need your computers with, we're going to do an activity on there. Please turn to E5A. Okay? In your workbook. Yep, I will check that homework. I'll have those of you that were finished, I'll have you come back in just a minute. So, in this one, we're trying to find what's our unit rate going to be. Cost per what? Per 1 can, per 6-pack, per what? So we're going to try and find dollars, right? Cost, that's my cost, per 6-pack. And what we knew was what? What did you know starting off? It was 4, if we are looking at it, 4 6-packs for $6, which means you are going to start with writing $6, right? That's my cost, to 4 6-packs. You are trying to find out how much is 1 6-pack. Okay? Can we have decimals? Yes, because we're dealing with money, right? So you can have a decimal when you're doing that. So question 1 just says get the unit rate. Question 2 says write an equation. Equation should look like what? Y equals what? Unit rate times our x. And then that's how you're going to use it to solve these other ones. Because then it says, well, how about for 15? What if she spends 210? What is the y here? Cost, or is it the 6-packs? What is our y? Y is? Y is, right? Because y is on top. Cost, x is the number of 6-packs, right? So, those of you that finished